I'm David Baker. Today I'll be talking about musical memory, but really when I say musical, I mean melodic memory. And by melodic memory, I mean Isocrates tones happening after a while. But we'll get to that. So I just finished up my PhD where I was looking at melodic dictation, which is a thing in music school in which you have to be able to hear a melody and then be able to write it down. And it incorporates aspects of musical memory because you have to sort of be able to hear it and then think about it. And then it presents as an interesting chunking problem in the sense that how many notes really can you enter in musical memory before before you can't anymore. And that's the question I'm generally interested in. So if you want to get into this kind of stuff, you look at the psychology literature and you run into the George Miller thing at first, which sort of then gets updated. And people say, oh, the 7 plus or minus 2 item thing. And then basically some of the music educators start to run with that, like, oh, 7 plus or minus 2 items. That could be 7 plus or minus 2 notes, but maybe we should change that just a little bit because music's probably a little bit different, and there's a couple of different claims in music education literature about really what is the limits that you could remember in these sort of melodic dictation settings. But there's a problem in that, in the sense that if you sort of blindly accept this items for notes mapping, and that pretty much music breaks all the conventions that you're supposed to have when you talk about what are these things that fill up these slots of finite memory. So one thing that I was interested in my dissertation was basically addressing this from a conceptual level, and basically music breaks all the rules if you're supposed to do working memory research. And one of the two big ones being music is hierarchically organized as well as sequential, so you can't just think as note after note is filling up memory bins. And also, if you just think it is about it as just the notes, you run into this problem where you might have these 2 melodies here, and if you were have to dictate them or have them be dictated by your students, melody A would presumably be much easier than melody B. But if you're just, it's just about notes, you'd have to admit that these would be equally difficult to dictate because they have the exact same set of notes and rhythms just scrambled up. So I was trying to think of basically different ways to get around this problem of how you could reconceptualize how many notes you can stuff into memory. And I was, one of the things that I got into this past year was sort of reading some of Marcus Pierce's work on idiom and statistical learning. And there's this passage here from this article where it is talking about basically their theoretical grounds for using idiom and ideas from statistical learning as a grounds for memory, even though it's often used as a thing to talk about melodic expectancy. It has all these other successes that are sort of detailed in this article that he wrote last year. So the idea generally being, if you're not familiar with it, just sort of the inspiration from it, if you were at my talk at SMPC, is that you could have a little melody, and then instead of getting sort of the probability events that you would have from the statistical learning model and thinking about them as expectancy measures, maybe you could use them as sort of actual information content measures and imagine them sort of filling up the bin of working memory until you get to a certain point. Just sort of give us a better theoretical model of it, with the idea being that sort of more unexpected events, like that F jumping down to the A, would be highly surprising, but also you could think about it as maybe filling up the bin of memory more, as opposed to the leading tone resolving to tonic after stepwise motion is more expected events. You could probably jam more expected events into memory. So that was sort of the inspiration that got me into this. And then the nice way of thinking about this is that you could basically then think about what happens when you have different working memory capacities that people would have, or even basically train the idiom ground sort of model that you're training it on with the corpus to reflect different levels of expectancy in people. So that was the inspiration for that. So I kind of wanted to get at this question. I sort of made this claim in my dissertation, being like, oh yeah, you could use information content for this, and there's also a lot of other models from which to consider. And so instead of basically trying to make a really big experiment where I would get a bunch of people and ask them to do same difference tasks on melodies, I wanted to do a very specific awful task that I would give all of my friends that would tell me something sort of about the items, rather about instead of about the people, which would be how musical are you and how does that affect your training. So basically, I had my friends do this task, and by friends I mean everyone that I am professionally affiliated with that I know knows movable do solfege. And So what they would do is they would hear this cadence of the piano, and then they would hear a set of a certain amount of tones, and then they'd have to sequentially recall in movable do, solfege what those things are. So it's a very difficult task. If you don't have like Western Conservatory music training, you can't really do this task, but that's fine. I just kind of wanted to use this expert population for this idea. So to give you a flavor of it, because it's always better to show than tell, this is the one-tone condition. So you would hear this, and you'd have to quickly say, which tone was it? Oh, no. Anyone? Scales before, yeah, scales before, great. So some people have, nice. So if you like doing this task, yeah, this is basically what is in the one-tone condition, 2, 3, 5, 7, all the way up to 9 to look at this. So you get this nice data set here, and I want to just present some preliminary findings that I'm getting into. I've got about 39 people in the sample thus far. I'm going to hopefully harass more people to collect more data for this, because this is also my sort of first foray into getting into like getting data and trying to model it. So if people have opinions on this, on how I should model the data, I'd appreciate talking to her afterwards for questions. So in the single tone condition, the data kind of looks like this. You basically get reaction time and accuracy, which is a big mess. When I was going through it, you can then collapse across over basically key in the single tone condition. I wanted to check there weren't any sort of key effects, so I could keep the key the same throughout the rest of the experiment, which there weren't any. And then, so if you collapse across everything, you get this little profile here. And when I was doing my exploratory data analysis, I noticed it kind of looked like something familiar. So if you basically put it upside down, and it kind of looks like the Crumb-Hensel distributional profiles, which I wasn't sort of expecting at this, but it kind of makes sense in the sense that this is sort of an implicit measure for hierarchical organization of tonal materials. And if you, I basically then correlated the data that I had there with both reaction time and the percentage correct, and the one there was a nice correlation of 0.78, using some rank correlations. But then I plotted a lot of them against each other. This is kind of just more on the exploratory side, and you basically were able to show that both in accuracy and reaction time, you're able to mirror the distributional profiles that you come across in some of the music psychology literature. And then the multi-tone condition, the idea was to basically inspect this idea that if you hear patterns more frequently, they'd be easier to process. So for my dissertation as a psychological failsafe, I also encoded 783 different melodies from a sight singing corpus, so in case everything else is bad, I can give this to the community. And then I basically sampled different n-grams from the corpus, and then sort of randomly selected from 5 different quintiles based on the distribution of them. So you have like high frequency occurrence, mid frequency occurrence, all the way going down to patterns that only occur once. And that made the stimuli set for the multi-tone condition. So this is basically the data for all of the different stimuli here, which is what I was going to then try and model. So you notice at the bottom, you will see 5, 4, 3, 2, 1 is the easiest to recall, and 5, 4, raise 7, or raise 6, 7, 3, flat 3, 2, 5, 4, which only happens once, is on the lower side. And then it's colored by quintile. So the very dark purple is stuff that happens at the top quintile, whereas the other ones come from the other quintiles. So I tried to start to basically, I'm in a stage now of modeling it with all the different ways that you could properly conceptualize what you could sort of stuff into musical memory. So on the top left corner, you stuck a number of notes model, if you only just knew that. There's also, I use all of the Daniel Boone-Ziethen's fantastic toolbox, which is a bunch of symbolic things, as well as taking the average information content from an idiom model trained on the Berkowitz corpus that I encoded, which I took the stimuli from. And surprise, surprise, the idiom model, which was quite pleasing to see, right now predicts, it correlates most highly with the data set. I haven't done any sort of modeling to differentiate between statistically significant differences between these models, because I want to take more of a principled way to do it, and so I'll come here and present that. But if you do run some linear mixed effects models, just take like the number of notes model a contour model as well as the idiom model. It's very nice to see that if you, by just using this sort of statistical learning conception, you're able to get a marginal R squared of 665 on there. So taking the current take-homes from this is that the idiom model is best predicting the multi-tone condition right now. Sort of accidentally came across this. You can get the carbon pencil distribution profiles to a decent extent, sort of this implicit measure with reaction time and accuracy. And it's sort of, it was evidence enough for me to sort of think that it's sort of worth pursuing this idea that you could think about statistical learning, probabilistic prediction, and sort of this heavy learning as a worthy avenue of me to sort of now pursue post-PhD. So in the future, I want to sort of address some of the multi-collinearity issues that you get with symbolic data, talk about maybe there's a way to better predict that, and then find a way to actually do a proper model comparison to sort of see how you could best explain things. And additionally, I know in the abstract I said I would have a couple of other models in there, but writing the dissertation and all that was a bit more cumbersome than I planned. So I'm on the plan for it right now. So I want to use Peter Harrison's new InCon package, which does all these different sensory models of harmony, as well as a couple of other ones in there to talk about and get this issue of how many things, how many notes can fit in musical memory. So a couple of thank yous. The guy that does the JS Psych stuff, Peter, as well as all my collaborators at LSU. So thank you very much, and I'll take any questions if you have them.
Thank you. This is very fascinating work. I just want to be clear before I ask my question that you were using phrases as according to quintiles of how often they appear in the corpus, or any measure of idiom probability within the phrase itself?
No, within the corpus. So basically, I have all of the corpus in Humdrum, and I just sort of ran the context tool, and so I grabbed the 2s, the 5s, the 7s, the whatever.
Okay, yeah, so one of the things that I'm very interested in is the interplay between how expectation plays out within each one of these phrases, or in musical phrases in general, yeah. And then how that might, so how that might be related in this kind of give and take with, does it appear in the corpus a lot because it's very expected, or do you expect it behaviorally more because of the expectation because it's in the corpus a lot, or because there's something internally expected within the melody itself?
Yeah, so I guess one of the fundamental assumptions with this is that basically, if you're talking about statistical learning type models, is that like the idiom corpus that you would train the model on is some sort of representation of an internal understanding of basically pitch content and melody content expectations that you get from passive exposure.
Right, yeah. So I was just wondering if your design was set up in any way to tease apart, maybe there might be even, like cognitively, there might be even different memory systems at play of remembering something specifically, or remembering something statistically that comes after. So.
Oh, yeah, no, nothing's built into this thing, but hopefully future stuff I'm going to try to address those types of things, and then also vary it up so it's not just quarter notes and change the tempo and all that kind of stuff. So.
Right. Would I be right in thinking you didn't include note duration because you wouldn't have had enough statistics? Or
yes, it's all isochronous. So I just figured that that's not. I want to look at things like note density and like rhythm entropy, which also come out of the fantastic toolbox as well. But because it's just quarter notes happening after prime, I didn't include it.
Thanks for a great talk. I was interested, you started this talk with a connection to the working memory literature, to Nelson Cowan's book on visual working memory and slot models. And you never came back to that. So I was actually really interested in the choice of task here, because by your own admission, it's really hard, right? And so my impression is that the variance in performance in that task is going to be due to something other than working memory capacity, right?
Yeah.
Because it is actually really hard.
Yeah.
So I wanted to hear your kind of comment on that, whether you think that differences in subjects' performance in that task will actually be attributable to working memory capacity differences,
Yep.
and how you might move forward from that.
Yeah, so I got really interested in the working memory stuff via working my dissertation. My co-advisor, who does just straight up working memory and did her PhD with Nelson. And so in the dream world, I will have this basically experiment with some sort of like complex span tasks as well. We have this battery of tests that we use, like reading span, symmetry span, and actually a tone span task. And ideally, in a final modeling, you'd be able to sort of partial out the stuff that's due to working memory stuff, and then also things that might be then due to statistical learning. And then because of the fact that there's like this one Burrs paper that I also like from the mid-90s, where he basically talks about we have all these tasks of musical perception, but really what they probably are just really awful tasks of working memory. And to be able to sort of delineate those two out would be a nice thing to say, like, here are the domain general cognitive things, and here are the things due to actual statistical learning, if that was a way to like be able to parse those out and say, then you could like talk about developmental things and all that kind of stuff too. So if anybody is looking for postdocs in the next year for perceptual things amongst this project, I'd like to, maybe pursue that in the future.
So as we transition to our next speaker, we'll take one very short final question.
Yeah, I was just wondering if you've looked at all at individual patterns, if there are ones that correlate better or worse with idiom, because idiom doesn't predict everything perfectly.
Yeah, of course, yeah.
Longer range harmonic stuff is
Yeah.
under-sensitive too. Some of the patterns are more sort of based on harmonic regularities.
Yeah.
Others, and I don't know if you've looked at that at all.
Yeah, it's definitely something like I want to implement and have like, the full total model that you can like walk into the lab and ahead of time and say, oh, these are the things I have, and like, I'll tell you exactly what notes you can remember at this point. And I think that obviously takes implied harmony and all the other things like from like a music theoretic background. Obviously I want to incorporate those things, but at this point I think it's just like collecting models and like thinking, well, even if it's like a short-term task, you also have all the contour problems as well. And so it's just kind of messy and hairy, but I think that's what music researchers like. So, I think great question.